Hey, fourth graders, Mr. Ord here. Today we're going to start learning about comparing fractions. Okay, so let's take a look at this problem to kind of get us started. So we got some candy up here. Doug ate 1/2 of a candy bar. Lindsay ate 1/2 of a candy bar. Doug said we must have eaten the same amount of candy. Lindsay said we could have eaten different amounts of candy. Show or explain which student you agree with. So take a few seconds to think about that one on your own. Doug said we could have eaten the same amount. Lindsay says we could have eaten different amounts. Okay, let's take a look. So to answer this question, we're going to look at these two statements here. We cannot compare a fraction when the wholes are not the same size. We can compare these because the wholes are the same size. So if we, thinking of this, if we come back to here, Lindsay said we could have eaten different amounts of candy. Lindsay's right. Because if Lindsay ate this king size Snickers up here, and Doug ate this little fun size, and they each ate half, Lindsay would have eaten way more. That's why the first thing with comparing fractions is we can compare these because the wholes are the same size. We're assuming that they're the same, not different. That's why when we make equivalent fractions with the rectangle models, we make sure the lengths are the same length. It's very important. All right, so keeping that in mind, which is greater, 3/4 or 5/12? All right, so we're going to use our fraction wall to help us out with comparing, because our first strategy for comparing fractions, and up here, so 3/4 or 5/12, which is bigger, is we can simply model those fractions to compare them. And when we come here, we can use this website, our fraction wall. So we'll kind of find those fourths. Okay, our first one, 1/4, 2/4, 3/4. Okay, there is 3/4 modeled. Okay, now we're going to model 5/12. Let's find those 12. So there's the eighths, there's the thirds, 6. Hey, there's the 12s, and we need to model 5/12. Okay, 1, 2, 3, 4. Okay, there's 5/12, so you can see that right there. There's 3/4. Now we can compare literally the lengths, how much space they take up. And if we look here at 5/12, it's way shorter. It's way shorter than 3/4. So what that tells us is 3/4 is bigger than or greater than 5/12. All right, so that is the first way that we can compare fractions. I want to talk about a second way that is really efficient, and I'm going to type this up here. It uses the benchmark 1/2. So when we say benchmark, like a benchmark number is 10 or 100. It's an important number. It helps us think about other numbers compared to it. So we're going to use 1/2. And so I'm going to kind of model 1/2 right here. So if we use 1/2 to help us, let's first think of 3/4. All right, so if we look at 1/2 and 3/4, it would only take 2/4 and 1/2 are equivalent fractions. But we have 3/4, so 3/4 is bigger than 1/2. Okay, so now when we come down here to 5/12, well, to get an equivalent fraction to 1/2 with 12s, we would need 6/12. 6/12 is equal to 1/2, but we only have 5/12. So 5/12 we can see is less than 1/2, and 3/4 is bigger than 1/2. So I know we have the visual here, but if we thought about it that way, if we knew that, hey, 3/4 is bigger than 1/2, and 5/12, I know is less than 1/2, we wouldn't have to model, and we could quickly know that 3/4 is bigger than 5/12 just looking at the benchmark 1/2. All right, let's take a look at another one. So let's think of this one right here. 2/5 or 4/6, which is greater. So we're gonna take a look at this. We're gonna think about it in terms of 1/2, because you could quickly model on here 2/5 and 4/6 and see which one's bigger. But if we were to go with thinking in terms of the benchmark 1/2, okay, so 2/5. Let's find where the fifths are at. They're down here. So right away, 2/5 is less than 1/2. And if we think about 4/6, I know those are the 8s. Where's the 6 at? Oh, they're there. It takes 3/6 to equal 1/2, but we have 4/6. And 4/6 is bigger than 1/2, and 2/5 is less than 1/2. So if we didn't even model and we got rid of these, I could just think of 2/5 is less than 1/2. And we saw that here, right here with the 2/5. And I know that 4/6 is bigger than 1/2. And we saw that here. That means that 4/6 has to be bigger than 2/5. Alright, so keeping that in mind, the focus today is really on 1/2 and that benchmark. So I'm going to show you what you're working on. So you're going to look at each fraction below and sort it into the correct category. If you get stuck, use the Fraction Wall website to help. Okay, so we'll open that up. It's the same thing that I was already looking at. Let's come back to here. Okay, so here's one category, less than 1/2. Here's exactly 1/2, more than 1/2, exactly 1/2. You're going to see there's some examples here. So 3/7 and 1/15, both of those are less than 1/2. Exactly 1/2, 6/12. Those are equivalent. More than 1/2, 11/12, and exactly 1/2, 12/12. Okay, so let's look at this first one, 7/12. So if I think of this in terms of the benchmark 1/2, it only takes 6/12 to equal 1/2. I have 7/12. That means it is more than 1/2. But let's take a look at it. If you're stuck, if you didn't get that, if you're like, I have no idea, you come here. All of these are being compared to 1/2. So we'll come here, we'll click this, 1/2. Let's find the 12s. Right here, 2, 3, 4, 5, 6, 7/12. If we compare them right here, coming right down, hey, we can see 7/12 is indeed bigger than 1/2. That's why we put it right here. What I would probably do is go like this and erase it. Okay, the next one, 1/4. Well, I quickly can know and have memorized that 2/4. So if we have 2/4, that's an equivalent fraction to 1/2. We only have 1/4 here. That tells me that it's less than 1/2. And we can, once again, if we got stuck, we'd come here, let's clear the board. Our focus is 1/2, less than, exactly, more than 1/2, or exactly 1/2. We have 1/4. Here's 1/2. There's 1/4. You can see 1/4 is less than 1/2. So we would type it right here, and we would erase this. Okay, there's the ones you got left. Reach out to your teacher if you get stuck.